8:45? Okay, I'll do that.
Okay, so I'm going to show you a couple different environments of getting work done, ways to get work done in Spark. There's a bunch of different ways. And there's some new stuff that we could talk about if we have time. But so I have a VM running here. I'm actually running the WhatWorks sandbox, which is called HTTP, WhatWorks Data Platform. So just by way of note, you know, it's consuming the RAM on my local. So this is sort of like the antithesis of running in a cluster, running on a laptop inside a VM. It just gets worse and worse.
Is there a way to increase the font size? Because that's pretty tiny.
No, you don't have to read that. I was just showing it to you.
Oh, got it. Okay. All right, no worries.
Yeah, so this is what, this is the Embari Management Console. Shows you all the services. This is not a big deal except to show you that we have a running cluster up here. And what we're going to do is, first thing I'm going to show you is, I'm going to use some notebooks and then we're going to hop over to Databricks in a second. But there is a notebooking, there's several different notebooking technologies, one of which is called Apache Zeppelin, which is loaded here on this sandbox. Now, so the main purpose, I guess, you can see Zeppelin is running right here as one of the services, right? The main purpose of Zeppelin and those types of things is data science, but it's not just limited to data science, it's any code that you want to run. So what happens is, like Zeppelin has all of these various interpreters. So here's the Spark interpreter and the parameters, and there's a Markdown interpreter, and there's Angular to run JavaScript, and there's Shell for doing Shell stuff, and Hive, et cetera, et cetera. There's a long list of interpreters. So that's just a way of referencing, like, how is this data running? So like I can start, I don't know, I maybe should have restarted the, once that finishes, I'm going to restart the interpreter. So I don't remember if I restarted it. Okay, that's all right. So I could just basically have, and the way that these notebooking tools work is, okay, I've got a lot of different things I could do. I've actually worked, these are four that I worked at for a workshop that I did. Most of these other ones come with Zeppelin. So if you want to run Zeppelin and like I said, it's not that primarily data scientists use notebooking tools, but they're also good for just getting started, and they can help you, get started with Spark. So basically, I'm able to run shell commands right here. So I've got a crimes database. I think it's San Francisco crimes. So what I did is I can do. Can you guys read this? Okay.
Just barely.
It's a little small.
Yeah.
Zeppelin freaks out if I go too much bigger, but let me try.
Oh, it was word wrapping stuff.
Okay,
That's good.
so I did a wget. I pulled down some data from the internet. The internet's working good. I did HDFS command to put it into HDFS, that crime data, and then I did a load of a.
What's the error over there mean? In your first cell, all the way to the right.
Oh yeah. Maybe I'm not connected to the internet. I can rerun it.
Okay.
I already have the data out there, so I wasn't too worried.
Oh,
about
gotcha.
it.
Okay.
Okay, so it just, yeah, I don't know what the error is.
It's not overriding.
Could be that. I just don't need that statement there. Yeah, it might actually be out there. You know, I know in fact it is out there, so maybe that's why.
No worries.
That's what's going on. So already we have a use for notebooks is that we can, yeah, that was the problem. So I could do a delete first and then put it out there.
Okay.
So already we find out there's a use for notebooks. We can run code quickly and easily. So I've also loaded this dependency here, and this is the Maven coordinates, if you will, of that. So one of the cool things out here is if you go out and look for Spark packages. So when you are working with Spark, there's this cool thing, sparkpackages.org. When you're working with Spark, you're just getting like the core, but you're getting ML Live, you're getting Spark SQL, you're getting now structured streaming or Spark streaming. You're getting all this stuff. Now there's all kinds of other libraries out there. Lots and lots of, and this is the first place to go, Spark packages, because there's really, really cool stuff out here. But guess what? You know, you don't have to you don't have to have this all built into the Spark distribution. You can just go get the libraries. So if you want to work with Avro, and so if you want to load CSV data, you type in CSV and there's Spark CSV. So it tells you exactly how to use it, you know, what the different releases. Databricks put this one together. So it's a really nice thing to do. Spark packages, if you're a heavy Spark user, you're going to spend some time out there doing that kind of thing. So what I did was I loaded a dependency for that CSV library, that Spark CSV, which is available with Maven. You can pull it down with Maven as well. Now the first thing, so what we're doing is this data science notebook is just running a Spark shell in the background. So a Spark shell is going to create a couple things for you. Well, actually, to be honest, Spark shell doesn't create them, but Zeppelin did. So just understand what environment you're working in, whether it's Jupyter, Zeppelin, Beaker, or Databricks, and a lot of the notebooking tools will already create this stuff for you. The Spark context, SQL context, etc. Those things will be created. But I'm just verifying that in fact I'm running Spark 1.6, and I already have a SQL context. So this is like 101, first couple things that we're going to do, and this is from the previous time, but this means it's running. Okay, just finished. All right, so look what I did. I did an infer schema. So I'm loading this crime data, which has a header record in it, and I told Spark to infer the schema for me, which it did, and then I can just print the schema right there. So I already, first step of my, I just did my very first step of loading data, and I already have a schema for it. So I'm already well prepared to deal with it. So now I can look at this data and say, okay, this stuff came from San Francisco and surrounding areas, so I can already get a good look at this. Now, the notebooking tools will typically truncate to 20 rows or something like that, so that we don't have that problem. So that's what data.show does. And I can see the types like SC, I put that code in there. Type SC, that's, I have a Spark context and I have a data frame. Those are the types of those objects. Another good use of having a notebooking tool is just, hey, what the heck is this type? And if I was in Scala, I would just type the object itself. Now, since I'm using Hive context, SQL context, I thought that was going to be Hive context, but in fact, let me show you how to add I just want to know, okay, I come in here and I do a plus sign, and since I'm working in primarily Python, I'll do a print type of SQL context, because I'd like to know if that is a Hive context under the covers. Turns out it's not. All right. So I did a drop table here just in case, and now the next thing I'm going to do is, so this is Spark SQL. I'm using Spark SQL to do this. I'm going to register a temp table called staging, and then I'm going to do a create table, and then I'm going to populate that table using a select star from staging. So it's called a CTAS, create table as select. That's what that's doing. So I just created, now, why did I do that? Well, because now this data has actually been stored and persisted in a SQL metastore that I can go query it. In fact, I could, if I have time tonight, I can go bring up Tableau and go access that table that I just created. I can show it to you. So if you're going to hook up your BI tools or whatever, then this is one way to do it. Just go ahead and create the table and dump it in there.
So you can write even Scala also? You're writing right now Python, right?
This is PySpark, which is
PySpark?
Yeah. This is Spark using the Python API.
So you can do the same thing like Scala.
Yep. Yep.
Yeah, everything you've shown, anything he does here, you can do in Scala.
So the Zeppelin basically used for the data science people most of the times.
Right.
Quickly do the things, right?
Right.
Yeah, see that percent PySpark he's got?
Yeah.
He's actually flipping it into Python by instigating that.
Okay, so now, because it's in a table form, I can actually write
Yes.
actual select statements against it now. And so I'm going to select neighborhood. I just threw weapon in there, account from crimes database. And so that's going to give me, again, this isn't really, okay, so that completed. So now I've got this capability where, okay, maybe I don't want that weapon in there, so I can take it out, right? So, or I can drag it back down into there and group the data.
Something you might want to point out is that when you did the temp table, what you did is you made it so that any of the languages can now work with the data. Does that make sense? In other words,
Any SQL.
so you could drop into Scala and access the table and do stuff with it, or you could drop into R, correct? And is that accurate?
Well, so there is a Zeppelin context that Zeppelin provides for you where you can pass objects to and from different languages.
Okay.
But, yeah, so I could put some, well, like we can just go up here and run one of the other Scala ones. So I think lab, here's,
Okay.
we'll run this in a second, but let me,
Sure. When you put it in the temp table, the point was that you could flip over to SQL context and you could see it. If you hadn't put it in the temp table in the Python context, it would just been some. That's how you're sharing it between the languages, right?
I'm really sharing it between, I'm taking it out of pure Spark context, out of Spark, and putting it into a table, a pure SQL table.
Gotcha. Okay.
So I happen to be backed by a Hive table in that case.
Oh,
so
I
I'm
see.
making,
Different.
basically creating a Hive metastore for it. And here's that same data right here in Tableau. So here we are, we've got, I made a filter over here with districts. So we can show all, but that's going to get too busy for Tableau here. So I'm going to uncheck some of these and go, if we just get back down to, this is the exact same data that I just looked at. I just created this, well, I created this table. Now, because of Tableau, I actually created an extract of this, and so this is already created extract from. But the first time I connected to Hive in order to pull this data in to this Tableau. Okay, so the idea is that I can get to the same data now for my BI tools, and that's something pretty useful.
So is there like just like a JDBC driver there that mimics the database?
There is a JDBC driver for, and so the notebook tools all come with a JDBC driver, and then Tableau has a JDBC driver as well. It connects, basically to the, it's like JDBC protocol. If I go back in over here, if I go upstream and try to do a new data source, then I can come in here and say, okay, I have a Hortonworks Hadoop Hive. Here's my URL. I can put localhost. I'm doing Hive Server 2 is what I'm running. I do have a username. It's called Hive, and then I connect to that table. And I don't know if it's going to connect to the Hive. I don't know how long that would take right now, but I think there's a default schema, so maybe look for that. And then a table name called, what did I call it? Crimes. So that's how I built it. Now, I don't have enough memory to run, so I have to go check my memory and see if I'm getting into the red yet. Okay, so let me go ahead and kill Tableau. Okay, so that's demo number 1 running on the VM here. Now the next thing, okay, so that's like 101, and we could do 102 here. We could run this data frames example next. Now, what I will caution you is you typically want to restart your Spark interpreter. So, what is this Spark interpreter, and what's really going on here? So that's basically the interpreter does things on your behalf. It creates your Spark context. It creates your SQL context. But then it's basically just a client of, it's another client. So when you're running, so what are the clients we know of? We know that there's Spark shell. That's basically just puts you in a REPL shell, and you can start typing away. This would be the Scala. Spark shell is Scala. There's also PySpark. So if you run PySpark, then you're getting Python API. If you run Zeppelin, or Jupyter, or Databricks, any of these, then these things are basically just other forms of clients that are these are all different types of clients that can connect to the Spark cluster. So that they're sitting in that box right there. there's a new thing called Libby server, which will allow you to do some, okay, so normally at this point in the class, somebody will say, well, I've got, a handful of BI users who want access to this, and, notebook, that's cool and all, but like I need this data to persist. I need it to be out there for long term because this team of people is going to come in and hack on it all day. So unlike some batch jobs that'll just start and finish, a lot of times what people are using Spark for is now to provide that basically that hydrated view, that already materialized view of the data. And so you want these things to go from short-term to long-term. You want long-running processes out there. So that's why these shells are really for, short-term use primarily. You're not going to, because this Spark context is living here, and if you lose this connection, guess what? The Spark context is destroyed and the job dies. So just be aware that in these shell environments, it's kind of like just for you. It's really just for you. But now in some of these other environments, when we get down to Libby, there are ways to make these long-term, long-running processes. And what Libby server does in particular, I'll show you a quick graph of it. So what Libby does is it's a way to connect multiple users to Spark, and it can be done for at least two reasons. One is sharing, context sharing. So you'll see that a lot in the new Spark documentation. It'll talk about context sharing. And so Spark 1.6 has what are called sessions. So for the web developers in the world, you know exactly what that is, right? The session is all of your state data. Okay, so Spark created sessions, and then these services take advantage of them. So what Libby does is allows you to either share context. So, Mark says, I've got to get this data up and loaded and ready for, BI user A, B, and C. They're coming in, at 10 o'clock whenever BI people get in. And so they're like, he's gonna run, and populate these data frames for those people when they come in. So he wants to share context, right? So he's going to use this model up here where he could log into the Libby server, kick off a bunch of jobs, get that data populated, and have it ready and available. When user A and B come in and C, they can get to that same data because they're sharing context. The inverse of that is isolation. Hey, Jim comes in later, it's like, no, I'm not interested in his data. I have my own data. I just want to use the Spark cluster and the resources out there. I need my own context. Stay away from me. So that's what Libby will give you that option to do that. Sharing or isolation. Okay, so we could walk through this in Scala. Basically, this is the Scala version of this, and it's the same thing. We're going to do is Z is the Zeppelin context, and that's where you can pass objects from one API to another API if you want to. You can do puts and gets on it. So, but instead of walking you through this whole example of just something similar in Scala, you'll have to trust me that it works. And then, because I'm going to show you, next thing I want to show you is, I want to show you the streaming example because we haven't really talked much about Spark streaming, but it's an important concept. I'm going to spend just 3-4 minutes on to introduce Spark streaming and the other components to you, and then we'll go back and show it to you working.
This particular concept is like, it's so state of the art. It's ahead of everybody now. This is some amazing stuff.
By the way, remember I talked to you about executors, and this is basically a history server of exactly what happened in one of those jobs that I ran. So you can see that I had 4 different executors here. The driver program is right there. This is their URLs. This is the amount of RAM allocated. So the executors got 879 meg each. They ran 66 or some number of tasks, the number of tasks they completed. total input sizes here. You can see that it's pretty evenly spread across. They each loaded about 16 or 18 megabytes of data. Shuffle reads and shuffle writes, those are those in between, when the transformations, when you're doing those map and then reduce, that data gets shuffled because the data doesn't live here forever. It's going to have to get shuffled to either a temporary disk store or RAM, hopefully it's RAM. It's going to move up here and it's going to be read out of here. And it's going to be loaded up here and down here. So shuffles are really key in determining your overall speed of your pipe is in this shuffle. You want that to be as small as possible. If you see some massive shuffles, then you probably want to rethink what you're doing. So this is like, either while you're running or at the end, what happened. So you can look at the jobs, each of the jobs. Remember we talked about jobs. You can even see an event timeline for when those jobs kicked off. You can look at the stages. So a job is one or more stages. I just happen to know that SQL uses a shuffle size of 200, so I know that was my SQL call right there. So there's these various shows. That was a show. That was a SQL call. Probably that was a create table. That's why it only has 2. But that was a select, I think, and a select and a show. So that took 200 stages. That tells me that it was a SQL shuffle because that's by default that's how many you get. So that means that you're going to, on those partitions up here, you're going to get 200 of these on a standard SQL transformation. So you can get a lot of data out of here. You can look and see, now that we didn't ask for anything to be cached. We should have talked about caching. We'll see if we can get time. Okay, so what I was going to show you last, or second to last, is this Twitter streaming demo. So I will connect to Twitter in a second. But let me go ahead and talk to you about streaming in SQL. So one of the reasons that people use Spark is because it's not just one thing. It's not just for machine learning. It's not just for graph. It's not just for SQL. You get all of it. So it's a nice language where you can bring data in and do lots of different things with it. Spark SQL has been around for a long time in our terminology. So way back in the middle of last year, in full release version 1.0, you can access it in all of the basic 4 high-level APIs. I think I already mentioned you can use Hive UDFs, Serities. Serities are serialized, deserialized objects. And more recently, you can now connect directly to over JDBC. So once Mark runs his job and gets these data frames populated out there, somebody can come in and connect over JDBC or even ODBC to get to that data. It's kind of what it looks like. Tableau up top, those BI tools, connecting over JDBC, talking to the Spark SQL context, and then these are the various data and metadata stores. So Parquet, Orc, those are optimized row columnar formats, different types of data. As I mentioned at one point, Spark natively understands and has embedded JSON support, so you can call on JSON file to load a file and automatically parse it. Then you can work with that as a JSON RDD from that point forward. All right, so a couple of things on streaming, and then we'll go show you the demo. So Spark Streaming originated with a paper that was talked about called discretized streams. Is anybody else I think I already asked this, but is anyone else using streaming architectures? Okay, what do you guys use?
IBM InfoSphere streaming, but we moved out because its licenses are expensive, so we moved to the C++.
Okay. And what are you using?
Kafka.
There you go. Yeah. So these are real-time streaming technologies. I mean, that's actually, I did a talk 18 months ago when we started DFW Data Science. The first session that we had was over Storm and Kafka and streaming architecture. So streaming, there's a lot of emphasis being put into streaming systems today. You'll hear about, I mean, just a myriad of things. You'll talk about, there's Apache Flink that's out there now. I mean, Kafka, if we go on back to like, RabbitMQ and stuff like that, all different messaging systems, but we talked about the advent of streaming systems that, like Apache Flink, like Apache Storm. Storm was developed by Nathan Mars when he was at Backtype and then moved to Twitter. So Twitter was the first heavy user of Storm. So Spark wanted to be in the streaming game too. And so they created discretized streams, and they can ingest from all the various, the usual suspects: Kafka, Flume, Twitter, ZeroMQ, which is what Storm uses. So, and Kinesis is an Amazon real-time streaming component that's available on the Amazon cloud. So basically, okay, so a lot of these systems take in a single tuple. That's a Python term that means a data item. So they work on them a single data item at a time. And we might call those events. So streaming data is like basically you're gathering event data from the world. So you might have, if anyone in here has Progressive Auto Insurance, you can get a snapshot reader that you put into your car, and basically it transmits data the whole time you're driving. So they can capture your speed, how many times you stop, how quickly you stop, what your average amount of mileage you drive every day, what time of day you drive that mileage, etc. So you can think of it, it's an always-on system, right? If you're driving at midnight, it's on, generating data. So the data comes in this stream fashion. But there's two kind of different ways of dealing with that data. One is deal with a single item and then move it on its way down the pipe. What Spark Streaming does instead is it works on batches of data, and they call it microbatch. Okay, so it doesn't look at a single event or item. It looks at a whole series of them, and that's called the microbatch. Here, these lines of code should work. If you want to create a streaming context, you should be able to do that. So all you have to have is a what? An SC is what? Spark context. You pass that Spark context in, you create a streaming context out of it. It says I'm ready to do streaming. That's the microbatch window right there. Seconds 5, that says I want every microbatch to be 5 seconds long. So data is going to come in for 5 seconds, then it's going to be wrapped up and shipped downstream and say, okay, here's the first microbatch. 5 seconds later, the next microbatch. And there's a Twitter utils, and I think that may be under that Spark packages, Twitter utils, that's available. And actually, I think it may actually even be packaged in with Spark. I think I looked that up once. I was amazed to find it packaged with. So now what it does is now once you get that data, you can apply SQL transformations to it. You can do normal batch processing as part of ETL. You can feed it into machine learning. You can start doing predictions. If you're feeding credit card transactions in, you can feed it into a prediction engine and get answers out. This is really the picture. Okay, so we have a receiver that's getting these input streams. It's shipping off batches of data every 5 seconds, right? And passing them to the Spark SQL context or the Spark streaming context. But the idea is it is a time-based view of data.
Does it only batch things by time? Is it?
Yeah, you can't. Yeah, it's by time, and so let's compare it. So why did they do that? Well, let's compare Spark D streams to one at a time or a single item at a time systems. This would be like Storm. Storm would be in this category. I'm not sure. I can't remember about Flink. There's a bunch of other systems out there too. Samza. I have a slide that shows all of them. But at any rate, so what's the advantage? Why do it? Okay, so there's a couple of different aspects that we should look at. One of the most important is latency. So if you're doing if you need a very, very low latency action taken on an event, let's say you're monitoring someone's heart rate in a hospital room. That, there's lots of reasons. If you're doing fly-by-wire, I mean, all the airplanes that we ride on these days have digital fly-by-wire systems. So those kind of systems need very fast feedback. If the aileron moves, it needs to be, very, very low latency to react to that. So low latency systems do better with these systems like Storm, one at a time processing. But if you're okay with 500 milliseconds, which in real time, that's like really, really, really long, right? Half a second is an enormous amount of time in real-time systems. So, but if you're okay with that, sacrificing that latency, then you can actually generally get higher throughput with Spark Streaming. You can move more data through the pipe in a given amount of time, so your throughputs can be higher. Just last thing I'll mention is the straggler recovery. So you might have these tasks running out here, and every once in a while they won't finish, or they'll just be slow. And that might be because, I don't know, this shuffle got filled up, and so there was no more room, no room here. It could be that the disk failed underneath it. It could be that the gigabit Ethernet had a problem. It could be that the whole node went down. It could be lots of things. So in these kind of distributed systems, you generally want to think about how you recover from those. So what Spark does is automatically it will, if it's launched past T1 out here, T1, T2, T3, and T4, and these three have finished. They're all done and taken care of, ready to be reduced. This one is going on, for, I don't know, a second or two. Then it can launch T5 out here to do that exact same task. And whichever one finishes, it will use the output from. So that's called speculative execution. Spark will do it for you automatically. So that's a really nice feature to have, is that once in a while, it's like you say, or like they say, you're only as fast as your slowest stage in a pipe, right? So that's something to keep in mind. So let's go show you this, if we can, show you this demo. All right, so I'm actually going to, and I hope the internet's still, my connection's still running here. All right, so I'm loading these Twitter libraries here that are part of org.twitter4j. Another thing I'm going to do is, anybody know what NTPD is? Network Time Protocol Daemon. Mm-hmm. Twitter gets upset if your system clock is different than it and it just ignores you. It's happened to me before, so I just dumped that in here. I just created this cell to give myself an indication that it's running, so I just popped the shell command in there. Now, next thing I'm doing is, while this is running, I'm using these keys. So these are my Twitter dev keys. They're actually not, I don't care if you write them down. In fact, you can go out here and get them. I have, so I created a couple of Twitter apps, which, and I give this one out to students when I run workshops. And so if they, basically Twitter has like most things, a throttling. If everyone in this class was running with these keys at the same time, they could probably flag it as an inappropriate use and kill it. So that's why I create multiple sets, and those are for the...
So if you want a really frustrating time playing with this, do that.
Yeah. So so and let me go ahead and kick off. So Spark Streaming has a start command. It says, guess what? Because it's time-based, it's like you have to tell it when. You have to tell it to start. So let's look at the code there while we're waiting. So we're going to wait 60 seconds. And why are we waiting? Because what I did was I said, my micro batch was 2 seconds. I'm going to let it accumulate some of those 2-second micro batches before I query it. Now, there's another time window. If we scroll up and look at that other time window, it's 600 seconds, which is close to 10 minutes. So what I actually did, it's pretty simple. I mean, to do really, pretty decent data processing work, you can do it relatively easily. So I'm looking for these. I'm looking for Scala Top News. I'm looking for OFL on Twitter, which I found out today he doesn't really use his Twitter account. But I was looking for yours when I couldn't find it.
I don't actually have Twitter.
Scala, DFW Data Science is in there. Get a little love for DFW Data Science. Hadoop Big Data. So basically, what I'm doing is I'm saying, look at the code. So after I do an import, first thing I do is I create a streaming context. Next thing is I say, let's create a stream, and in this particular, the Twitter utils, I'm saying create a stream and look for this array of tags or names. Then then this other thing says, okay, I want to, what is that window? That window says, I'm going to process 2-second micro batches, but I want a view of 10 minutes. I want to be able to process 10 minutes of data every time I look at it. And so what will happen is, that says that after data is more than 10 minutes old, drop it out of the data frame. So this is all underlying a, guess what? It's an RDD sitting underneath that. It could be a data frame. This code's old. And I created this case class called tweet. It has just a couple of things. It has a screen name, a text, and a created at. So I have a timestamp. And basically I do that's a Scala for, basically that's a lambda expression, right? A anonymous function. So I'm doing a get created at, get text, get user, get screen name. So those are the items I'm pulling into that case class called tweet. All right, so now I can go out and try to look. So the last thing that happened up here was I created that temp table. Remember, we register temp table so that we can work on that data with real SQL, with raw SQL commands if we feel like it. So let's see how the internet connection is holding up.
If you hadn't written the temp table, it would have required you to have done it in the SQL, in Scala, correct?
You can actually write this in data frame language. You could say data frame dot created at. You could say so instead of, and there's a dot group by.
But that would be in Scala. In other words, you would be you'd be writing Scala.
Dot group by dot, yeah.
Right.
Instead of SQL, you'd be writing Scala.
So when you put it into the temp table, now you can actually write against it in SQL instead of having to use Scala. Is that accurate?
Yeah.
Okay.
Yep. Yeah, I can do that. So that's where, so there's our data. We got, so look, these are the different, here's the 2-second chunks. These are the micro batches. So sometimes I got 2 tweets. Sometimes, I normally got 1, but some of them had 2 tweets in a given.
It's 275 just to let you know.
Okay. Yep. Cool.
Is there a reason to prefer Scala or PySpark or SQL over one or the other?
No, it's really, I mean, that's kind of like the old question of which language should I write in. I mean, it depends on what your skill sets are in your team. There's obviously some difference in some of the execution times. You should compare those, but that's why one reason you don't use RDDs anymore, because you want to have that catalyst optimizer involved. You want tungsten involved. So luckily, but remember, as I said, that SQL AST thing feeds into the catalyst optimizer. So this code is going right through the same optimizer as the Scala code would. Okay, so then I have a sentiment analysis. I have some words that I consider to be positive, some that I consider to be negative. I'll do a regex, and then let's go look and see what happened. What were these? Let's see if we can dump out some text. Okay, so these just came in a few seconds ago based on the terms that I asked for. Learn how to speed up big data. So this is where you always fear that something really nasty is going to be in here. But looks like mostly we avoided that. So smart enough cloud, IoT cloud, smart enough robots, etc. Now I don't know if there's any Scala stuff in here. So the nice thing is, remember, I'm collecting data for 10 minutes. So if I come back here,
Oh no.
it's all right. It's just a browser refresh. It should be just fine. I hope. So if I come back in here, remember, I'm actually collecting for, like, my view is holding 10 minutes worth of data. Now this was, so that was I can't read that, but 143 UTC. But it's probably not 10 minutes, right? It hasn't been 10 minutes since I launched it. So I'm going to go back and, so I had, I don't know, maybe 15 or 20 tweets there. I should have more now because really nothing should have fallen out of the 10-minute bucket, right? So I'm bucketing by 10 minutes. I guess you can think of it that way. Bucketing and windowing, however you want to think about it. So here, I still have my 2-second micro batches, but now I've got a lot more history built up until this gets 10 minutes long. So now I have more data, and I can see, maybe there's some Scala stuff in here.
So you can still query in the middle. While
that?
filling up the bucket, right?
Yeah.
That's what it is. What you mentioned.
Right, so those micro batches are still happening on 2-second intervals, but I specifically ask it to retain 10 minutes of data inside the RDD.
Okay.
So that RDD is just getting written to, it's just getting appended to.
Right.
And at some point, stuff will start to fall, like a FIFO queue. The old stuff will fall off the back, and the new stuff will continue to fill.
So basically you have 10-minute window moving.
Yes, I'm moving.
Yeah, that's my 10-minute view of the universe that I'm, So now there's some more stuff in here, banking industry. A lot of the same tweak. And again, this will be truncated, so I might have to tell it not to truncate the output. And here's the actual text data. So now I can say, well, how did that fall out? How did that break out in terms of sentiment? Now I have about 40 or so tweets. It's running, but how did it break out between positive, negative, and neutral? If none of those words showed up in the text, I can do that. All right, so we're at 10 till 9. I can show you, so there's the graph there. So what I can do is I can show you for a couple minutes what Databricks offers when you're running. Okay, so I told you earlier, you can go out and get, if you go to any of these courses, so these are some of the courses that I suggest to you for, of course, start with that one, but these are all from EDX. These are the massive online open courses, the MOOCs. I've taken several of them. What you'll end up getting is you'll get access to a Databricks Community Edition, which is yet another browser, yet another notebook environment. So we got Jupyter out there. We've got, Jupyter came from IPython. So there's IPython, there's Jupyter, there's Beaker, and there's Zeppelin, and there's also Databricks. So all of these various notebooking tools. So remember we created a cluster, and that cluster called Scholar Group, I don't know if it's been an hour.
It is, it's a terminated.
Yeah, it already shut down.
It's shut down.
Mm-hmm.
All right, no worries. We can. All right, so let's go into a gentle introduction to Apache Spark on Databricks. So now what we can do is we can say, okay, there's no cluster up here. I need to go create a cluster. So I'll just say demo this time. Create cluster, and that'll come up in the background. So that if I sit here, it's like it's allocating that. And again, this is a really small. It's like 6 gigabytes of RAM, 3 cores, I think it has. And that's sitting out on Amazon. They use Amazon infrastructure. But I can go ahead and read through this. What am I going to do here? Workspaces, notebooks. This is just kind of an intro to Databricks itself. Getting you used to how to run the environment. New cluster, that's what we just did. We just launched a cluster. You can choose the availability zone among 3 different choices. And then basically, when we're ready, if it's ready, it's not quite ready yet. It's still pending. But once it's been allocated, we can attach the notebook to it. So that's what we'll do next. And if you want to import, you can export this as a Databricks Cloud Archive, DBC Archive. You can export it as an IPython notebook, or just as a Python source file, .py. And so then you can grab that code and take it somewhere else with you. You can even put it into production systems. All right, so I'm going to go ahead and attach. So now it says we're attached. So we can do a restart, and I'm going to kick off this the UI over here in this other window, and it's going to sit out there and wait for me to do something. Okay, so I'm going to prove that those things exist. I'm going to just do a range call. Yeah, I haven't called this in a while. So this is just sort of like playing around in the environment. Create a data frame, take 5 items from them. Now, interestingly, you can see the jobs and the stages right here from this. But if you go over to here, then you can. Oh, it's having trouble connecting. Come back to that in a second. Okay, so they walk you through, pipelining, and remember the physical and the logical clusters and all this. Here's the Catalyst Optimizer. So this is mostly just documentation about Spark and about Databricks. But they also have a Databricks file system. So they have a DBFS out there that you can use, and that just showed that we wrote to the Databricks file system, which is just a layer on top of S3. We can infer the schema like we did before. We have a CSV file out there, and then we can just use this display. So Databricks has this display function that they build in. That's only available, that's a Databricks function they call in their library. So, you know, you've got structured data, you just want to see it. It'll plot it out for you best it can. So, I don't know what this data is, but anyway, so they use a Databricks file system to back. Now, if we just say what's going on with my cluster, I can go look at that. Is it using spot instances or not? Let's go check on the UI for some reason. Being stupid, I don't know why. Let's relaunch that. Maybe I launched it too soon. Go back to my workspace and go back to where I was over here. One nice thing I'll just mention is they have these trainings. So this is their little navigator, but it's real nice because they have all these training courses, and you can actually go in here with and this is, I think, available to anyone who has a community edition. You can actually look at all the coursework for all of those classes. So there's CS105, CS190, there's 100. So you can actually go through and look at all the modules. And some of these are, you know, simple word counts and stuff like that, but then they get into machine learning. So you have access to all of those sort of tutorials that they've developed. It's a good way to, you know, this is all free, so it's a good way to get up and running if you want to go run something. I'm going to go back to my user called Argus, and I think I was running that one. Right after the graph. That's basically where we were. So we have some data, we graphed it. And just like Zeppelin, they also have graph options. You can say, okay, what are my plot options? Here's all the fields. I have keys and I have values and I have groupings. And I can do different things with them here. I can do bar charts, line charts, et cetera, et cetera. Different things that I can in the charting packages.
Do the other notebook tools let you do charts like that?
Yeah, Zeppelin has one also, a graph.
Yeah.
Let's see if I go to the UI now. Maybe So what the UI is hopefully going to show me is, yeah, here we go. So now we have jobs, we can look at stages, stage by stage of the things we've done so far. Let's look at the executors. Again, this is just a driver, so there aren't any executors out there. Again, it's a very small cluster, so it's just got the driver. And that's perfectly okay, you can just run a driver. You can see if you have any JDBC data, any SQL data out there. So these are the SQL commands that have been run already. If we cached anything, that would show up in storage, but we haven't cached anything yet. At any rate, it's a pretty flexible and easy environment to get through. So now, if you wanted to see, remember we talked about these explain plans, which the optimizer deals with.
Hey, Con?
You can actually,
Yeah, I was telling him he's interested in that. Hey, Casey,
Okay.
can you touch him right to the right of you? Hey, this is the explain plan thing I was telling you about. This is it.
Yeah. No, when you explained it in there, I understood.
This is where they kind of go into like excruciating detail about how it works.
Well, that's why they have the word AST in there, so that.
Yeah, that's the physical plan there.
that's the explain plan right here.
Yep, right there. Yep.
So you see tungsten exchange, you know, you gotta look at a few of these before you know what's going on. It's like reading Chinese or something. You know,
What's ingenious
Yeah.
about this latest version, though, is that they actually know they're talking to an Oracle database. So if you're actually doing a composed query across a set of data sets, and your filter is going to dip into the Oracle, when it actually attaches to Oracle, it will specifically push that predicate into Oracle. And so it's some really, really impressive tech.
Yeah, the way I visualize in my brain is that they have, like if you have language compiled to some machine called LLVM, right? So this thing does similar thing to that. At high level, you have a target language you put in there, which is, in this case, Oracle. So they do all of that fancy stuff, concurrency, figured out who can execute the order, and then they produce some stuff in there. That's the magic they produce.
Yeah,
I
kinda
mean,
like-
it's,
Right, so
it
you can
sounds
tell-
simple to explain, but it's very
Yeah,
complicated to
sophisticated.
do. I mean,
Yeah.
So you can tell when they're doing scans and when they're using indexes, et cetera. But I think you're talking about predicate pushdown, right?
Right, yep, probably push down, yep.
Yeah. Anyway, so we won't, I think we're out of time, but effectively, last thing I'll mention is about caching, because that's an important thing. If you're gonna, okay, so one of the very first things I said about RDD was it was resilient, right? So it has to know how to rebuild itself. And so as long as the Spark context is alive, it can rebuild itself. But if you've loaded 100 terabytes of data, you don't really want it to rebuild itself. You don't want it going back to disk. So what you can do is if you're going to hit that data frame over and over, you know that, hey, this is the golden record now. I've done all this transformation, all that other stuff I can forget about. But now this is the thing I'm going to operate on for the next hour. Then you cache that, and what that does is it keeps it resident in memory and lets all the other stuff fall out. So anything that's not cached will eventually fall out of memory. But this stuff says, hey, keep this resident, I want to hit this over and over. And that's what you do for machine learning algorithms. Once you get the model built and you're going to do predictions on that model, and you can cache the data that was part of that training set, or cache the data that was part of the test set, or you can cache the model itself. So caching, so there's a cache there's a dot cache, and there's also a dot persist. And you can configure where these go, but of course cache says go to RAM, persist by default says go to disk, but you can change the storage tier that these go to, all right? And then there's also an unpersist that says I'm done with this, flush it out. All right, so that's how you can sort of get control over what stays in RAM. Okay, so I think we're at 9, I think we're done.
This one last,
Any
because
questions?
all they have the virtualizing is a lot simpler to think about, but in reality, you have the machines underneath there, where you have a 4-core, 8-core, 12-core, whatever there, and then you have a separate machine where you have to transfer on the fiber or whatever they have to do to transfer them. Does the Spark, when you're this guy, understand the underlying architecture, so that you're trying to keep the machine within itself, right?
Yeah,
When
so it
early on
depends.
in your slide, you say that the Spark guy go out and say they have used less machines compared to the other people. Then maybe that they have one humongous machine, have lots of memory to put together, and therefore they're very efficient and they outrun them. I mean, I'm just wonder about, where all of that stuff in there.
Well, okay, so there is something in the Hadoop world and in the Spark world about rack awareness and those kind of things, but generally you're only concerned with rack awareness if you're talking about failover or fault recovery, those kind of things. Really, this is where you want to come. Like iTunes, like Spark. So there's Spark for 101 stuff, and then there's Spark tuning, which is a great big broad area. So Spark tuning is where you spend a lot of your time. So running on a local VM with my laptop, which has 16 gig of RAM, I allocate 11 gig of it to this thing. It took me a while to tune this just right, and I didn't tune it for this example. I have a machine learning example that is much, much bigger than this. And so I'm able to run it on my laptop after tuning things. But you do spend time trying to figure out how much RAM. So you have things, you can allocate a certain amount of RAM per executor. You allocate the number of executors, the number of cores, or what we call slots. Those are all like pieces of the puzzle that you're going to put together to make this efficient. And you want to watch the shuffle reads. Inputs you can't get away from. I mean, your data is going to be pretty much stored on disk somewhere. You
You
can't.
can buffer somewhere.
But you can, if you notice that, hey, only 2 of these executors are doing all the loading, then you want to look at splittable formats. Are my formats splittable? If they're not splittable, then they have to be read serial. If that first sc.txt file, you can tell it how many partitions you want the data to land in. If not, then you can repartition it once it's in there. Once you get to that golden record where you're going to hit that thing over and over, you can hit repartition on that. Say, okay, it's in 6 partitions now, I'd rather have it in 12 or 20. So you can repartition that data. There's also, there's a famous little example on reduce by and group by. So there's a, or not, group group by key.
Yeah, group by key, I believe, the one, yeah, that's.
So there's a group by key, and then there was what was the other one? It was another group by. I think it was just group by. Okay, so there were these two different ways. So what group by key is, if you had to aggregate these things together, it would run a group by key locally on each VM. So you would get the T1 group, and you get the T2 group, and the T3 group, etc. And so you would only basically group locally on the VM. So that was group by key, which was pretty efficient. But there was another one, and I can't remember if it was just group by, or if it was something else. But they actually ended up, in the later editions, removing this from the language because it was their number one, on their FAQs and on their support calls, it was the number one question that everybody was having. I think it was reduced by key, that was the other one. Group by key and reduced by key. That's really what it was.
Yeah, reduced by key, that's the one that went nuts.
Reduced by key, no, it's the other way around.
Okay.
Reduced by key, and then group by key, I think. So group by key was, hey, shuffle all you want. Shuffle all you want. So it could be like, okay, now when we're doing a group by, and it's like, okay, I could end up with some T1 data plus some T2 data plus some T3 data, and that's one of my shuffles. All right? So all this data was moving all over the planet just to be grouped. And then reduce by key says, no, reduce it first, and then send it up. Well, they actually, I believe, what I was told that they removed that from the language because it's never a good idea. It was always a bad idea. It's like, and they would always, they would tell you that it was not a good idea, but then they were like, oh, let's just remove it.
Yeah.
So the moral of the story is shuffling is bad, and shuffling costs you, and so try to avoid, do smart shuffling, reduce first. So these are various techniques that you have to learn to do. But like this is like the scorecard. Okay, so once you try all you want, you learn, you use all your tips and tricks and your documentation. You come in here to see if you did it right. This is your scorecard. It says you either did it right or you've got some more work to do. All right, thanks everyone for coming.
Thank you, Paul. That was awesome. Thank you.